You clicked this video because something isn't working. You're sleeping. You're not a mess. But by Thursday, you're running on fumes, and you can't figure out why. Here's the answer in one sentence. Your body has a master clock, and right now it's running 2 to 3 hours behind your schedule. Everything in this video is about fixing that, starting right now. Let's start with the basics. Inside your brain, in a region called the suprachiasmatic nucleus, or SCN, sits your master clock. It's about the size of a grain of rice, and it governs nearly every system in your body. Cortisol, melatonin, insulin sensitivity, core body temperature, immune function. All of it follows a 24-hour pattern driven by that single cluster of neurons. But here's the part most people don't know. That master clock doesn't run alone. Every cell in your body, in your liver, your heart, your muscles, your gut, has its own peripheral clock. These peripheral clocks are synchronized to the master clock through 3 primary signals: light, food timing, and physical activity. When all 3 signals line up, your biology is running on schedule. When they don't, you get what scientists call circadian misalignment. And circadian misalignment is not just fatigue. It's impaired cognition, disrupted metabolism, elevated cortisol at the wrong time, and degraded sleep architecture, even when your total hours look fine on a tracker. This is why I don't talk about sleep tips. I talk about circadian biology, because once you understand the system, the right behaviors become obvious. Let's go through each signal one by one. Light is the most powerful timing signal your biology has. The German word for it is Zeitgeber, literally time giver. Your SCN evolved to detect light through a specific pathway, intrinsically photosensitive retinal ganglion cells. These cells are most sensitive to short-wavelength blue light, around 480 nanometers, which corresponds to the blue sky at morning. When that light hits your retina in the morning, it fires a signal to your SCN that says, it's daytime. Start the cortisol curve, set the wake timer, begin the melatonin suppression window. Here's the practical problem. Most high performers wake up before proper daylight and spend the first 2 hours of their day under indoor lighting. Indoor lighting is typically 100 to 500 lux. Outdoor light on an overcast morning is 10,000 lux. Direct sunlight is 100,000 lux. Your SCN evolved to receive the latter. When it receives the former, it doesn't fully anchor your wake signal, which means your cortisol awakening response is blunted, your melatonin clearance is delayed, and your thermal rhythm doesn't peak when it should. The morning light protocol is simple, but it must be done correctly. Within 30 to 60 minutes of waking, get outside. Even on a cloudy day, you need 5 to 10 minutes of outdoor light exposure, without sunglasses, at eye level, not through a window. Glass filters the very wavelengths your iPRGCs need. This one behavior is probably the highest leverage circadian intervention that exists, and it's free. Evening light is the mirror problem. After sunset, your body expects darkness. What it gets instead is screens, overhead LED lighting, and the physiological equivalent of a sunlit afternoon, right before bed. The result? Melatonin onset is suppressed, sleep latency increases, and the timing of your entire next day shifts later. This is called light-induced phase delay. If you've ever noticed that going to bed at 11 p.m. still doesn't mean you're asleep by 11 p.m., this is likely why. The fix is to transition to low, warm, dim light after 9 p.m. Candlelight is an ideal reference point. It's around 1,800 Kelvin and very low lux. You can replicate it with warm lamps or, more practically, by dimming your overhead lights and shifting screens to night mode. The second timing signal is food. And this one is subtle in a way that surprises most people. The research on this comes largely from Satchidananda Panda's lab at the Salk Institute, the same researcher who coined the term time-restricted eating. But the mechanism isn't about intermittent fasting per se, it's about clock genes. Every cell in your liver, gut, and metabolic system has a transcription-translation feedback loop driven by genes called clock, AL1, period, and cryptochrome. These genes oscillate on a roughly 24-hour cycle. When you eat determines when those genes are active, and when those genes are active determines how well your cells process glucose, clear waste, repair tissue, and regulate inflammation. Eat at the right time and you're working with the loop. Eat at the wrong time, late at night, first thing in the morning before your wake signals are set, and you're pushing those peripheral clocks out of phase with your master clock. The practical implication is this. Your eating window should be anchored to daylight. For most people, A 10 to 12-hour eating window aligned with your active hours performs significantly better than the same calories consumed across an 18-hour window. Significantly better here means better insulin sensitivity, more stable blood glucose, lower evening cortisol, and meaningfully improved sleep architecture, as measured by deep sleep and REM duration. The study you want to look up is Sutton et al., 2018 in Cell Metabolism. They found metabolic improvements from time-restricted eating even with no caloric change. Timing alone moved the needle. 2 timing points that most people get wrong. First, morning coffee before food. If you're drinking coffee within the first 90 minutes of waking before eating, you're elevating cortisol on top of the cortisol awakening response. Cortisol and caffeine work through overlapping mechanisms. Stacking them produces a sharper spike and a harder crash. A better approach: let the cortisol awakening response complete, roughly 90 to 120 minutes post-waking, then have coffee. Second, the last meal. Research consistently shows that eating within 3 hours of bed degrades sleep quality, specifically the deep sleep stages in the first half of the night. Aim to finish eating at least 3 hours before your target sleep time. Most people think of sleep as a single thing. You're asleep or you're not. 8 hours is good, 6 hours is bad. But sleep is not a single state. It's an architecture, a series of 90-minute cycles, each containing light sleep, deep sleep, slow-wave sleep, and REM. And the distribution of those stages across the night is not random. It's circadian. Deep sleep is front-loaded. The majority occurs in the first third of the night. EM is back-loaded. Most occurs in the final 2 hours before waking. This matters enormously for what you're actually trying to optimize. Deep sleep, specifically slow-wave sleep, is when your brain clears metabolic waste through the glymphatic system. It's when growth hormone is released. It's when memories are consolidated from working to long-term storage. REM sleep is when emotional regulation is processed, pattern recognition is enhanced, and creative association between ideas is formed. If you're cutting sleep from the back end, setting an alarm before your natural wake time, you are disproportionately cutting REM, not just the total sleep. The specific stage that governs your social cognition, your emotional resilience, and your ability to think non-linearly. That's what the morning alarm is actually costing you. Circadian temperature is the most overlooked variable in sleep. Your core body temperature follows a 24-hour curve. It rises through the day, peaks in mid to late afternoon, then drops. And this temperature drop is the trigger for sleep onset. It typically occurs 2 to 3 hours before your natural sleep time. You can accelerate this drop, and therefore fall asleep faster and get better deep sleep, by warming your skin before bed. A hot shower, a bath, or a sauna in the 60 to 90-minute window before bed causes peripheral vasodilation. Blood rushes to the surface of your skin to dissipate heat, which accelerates core temperature drop. This is why a warm bath makes you sleepy. It's counterintuitive, but mechanistically precise. Exercise is a powerful circadian synchronizer, underestimated because the fitness conversation focuses entirely on what you do, not when you do it. But timing matters a lot. The general principle: exercise in the morning anchors your circadian phase earlier. Exercise in the evening can shift it later. Both have their place, but the effect on your schedule depends on which direction you need to move. For most high performers trying to run an earlier schedule, earlier wake, earlier performance window, earlier sleep, morning exercise is your primary lever after light. It elevates core body temperature early, produces a cortisol peak at the right time, and reinforces the morning anchor for your peripheral clocks. The best time for this type of training, 6 to 10 a.m. Strength training and high-intensity work in the morning builds your thermal peak earlier in the day. That thermal peak drives your afternoon cognitive performance. There is also solid data showing that testosterone and grip strength are higher in the afternoon, specifically around 3 to 6 p.m. So if pure physical performance is the goal, late afternoon training yields better output. The key is, don't train within 3 hours of your target sleep time. Intense exercise elevates core temperature and cortisol, both of which oppose sleep onset. One specific note on late afternoon training and performance. There's a natural alertness dip that occurs in most people between 1 p.m. and 3 p.m., driven by a circadian phase in your adenosine system, not just by lunch. If you schedule light exercise during this window, a 20-minute walk, a brief mobility session, you can significantly blunt the dip and extend your afternoon cognitive window by an additional 90 minutes. This works because movement increases core temperature, which is alerting, and clears adenosine locally in the muscles. Combine this with strategic bright light exposure at the same time, and the afternoon dip becomes nearly irrelevant. Now let's put this together. I'm going to walk you through a complete 24-hour circadian protocol. This isn't a morning routine, it's a full biological timing map, designed so that every major system in your body is aligned and peaking when you need it. Wake phase. For the first 10 minutes after waking, no phone, no screens. Let your nervous system come online before you hand it to an algorithm. Then get outside within 60 minutes. You already know why. Coffee at 90 minutes, not before. First meal at 90 to 120 minutes after waking. Peak performance phase. This opens roughly 2 hours after waking, and it's your highest cognitive window of the day. Deep work goes here. Your prefrontal cortex is running at full capacity, cortisol is at its functional peak, and your working memory is sharpest. Don't waste this window on email. Your biggest meal of the day goes here, not at dinner. A 20-minute walk around the 1 to 2 p.m. window blunts the circadian dip before it starts. If you're going to nap, keep it under 20 minutes and finish it before 3 p.m. After 3 p.m., a nap will fragment your night. Afternoon phase. 3 to 6 p.m. is your thermal performance peak. Fine motor control, reaction time, and physical strength are all measurably higher in this window. If you're training for output, train now. Begin winding down your food intake. The eating window closes here. Evening phase. Lights dim after 9 p.m. Last meal already done. Hot shower or bath 60 to 90 minutes before your target sleep time. Bedroom temperature between 65 and 68 degrees Fahrenheit, 18 to 20 Celsius. And the most important variable of all, your sleep time is consistent. Same time every night, including weekends. The most important thing about this protocol is not any single item. It's the consistency of the anchors. Your circadian system does not respond well to variation. Every 90 minutes of sleep timing variability across the week is roughly equivalent, in terms of circadian disruption, to crossing a time zone. If you wake at 6 a.m. on weekdays and 9 a.m. on weekends, you are giving yourself social jet lag twice a week. Your clock has to re-anchor every Monday morning. This is why high performers who track their sleep data often find their worst performance days are Monday and Tuesday. The recovery from weekend misalignment. Consistency of timing across all inputs is the foundational variable. Get that right, and everything else works better. Let me quickly cover the 4 patterns I see most often in people who feel like circadian optimization isn't working for them. Pattern 1. You wake up fine, but crash by 2 p.m. The root cause is almost always a blunted cortisol awakening response, usually from skipping morning light or stacking caffeine too early. Fix. Outdoor light within 30 minutes of waking, delay your coffee. Pattern 2. You can't fall asleep even when you're tired. This is light-induced phase delay. Your melatonin onset is being suppressed by evening light exposure. Fix. Eliminate bright overhead light after 9 p.m. Add a hot shower 60 to 90 minutes before bed. Pattern 3. You're getting 8 hours, but waking up foggy. Late eating or alcohol within 3 hours of bed is degrading your slow-wave sleep in the first half of the night. Your total hours look fine, but your architecture is broken. Fix. Last meal 3+ hours before bed. No alcohol within 3 hours of sleep. Pattern 4. Your energy is inconsistent day to day with no clear reason. This is social jet lag. Your wake time is shifting by more than an hour between weekdays and weekends, and your clock is re-anchoring every Monday. Fix. Lock your wake time first, even on weekends, and everything else stabilizes around it. If you're still not seeing improvement after implementing this protocol for 2 weeks, not 1 week, 2 weeks, because the circadian system needs time to shift, there are 2 other variables worth investigating. First, chronotype. Not everyone's optimal window is the same. If you're a genuine evening chronotype, forcing a 5 a.m. wake protocol will work against you, not with you. Understand your chronotype first, then build a protocol around it. Second, your environment. If your bedroom gets any meaningful light before your wake time, that is resetting your clock prematurely and fragmenting your late cycle REM. Blackout curtains and thermal management of your sleep space are not optional upgrades for serious circadian optimization. Here's the summary. Your body runs on a 24-hour clock that governs every system that matters: cognition, metabolism, recovery, and resilience. That clock is synchronized by three primary signals: light, food timing, and movement. When those signals are aligned, your biology works for you. When they're scattered, which is the default for most high performers, you are fighting your own operating system every single day. The protocol in this video isn't complex. Morning light, anchored eating window, consistent sleep timing, temperature management. It requires almost no additional time. It just requires you to do the things you're already doing at the right time. That's the leverage point. Circadian biology doesn't ask for more discipline. It asks for better timing. Start with the one change that will have the biggest effect for most people watching this. Get outside within 30 minutes of waking every single morning for the next 2 weeks. Notice what changes. Then come back and watch the videos linked in the description. Each one goes deeper on a single lever. If you found this useful, subscribe. Every video on this channel is built on the same principle: specific biology, applied to real schedules, no supplements required.